Today we're going to have a look at the 4NEC antenna simulation software editors. This is the way you enter in your creations into the antenna simulator, so it's very important. There are a number of editors available, but before we have a look at that, let's just get a little bit of basic theory out of the road. The way that you actually enter information into the editors is in three dimensions. You have to define an antenna as a point in three-dimensional space. Now, we use the three-dimensional coordinate system, x in one direction, y in the other, and z as the height. So that's all there really is to it. Now, each wire is defined as a beginning and an end. So each end of the wire will have an x, y, and z coordinate, and the other end another x, y, and z coordinate. And that's really all there is to it. Now, segments. As I mentioned in the first tutorial, NEC works by chopping up a wire or radiating element into a number of little chunks. Each chunk is called a segment. Now, the number of segments is defined by yourself. You could use 1 or 10 or 100. It all depends on how you wish it to be, how accurate you want it to be, and so forth. You don't really need a lot of segments for the sort of work that we do. 10 segments is more than enough for most of the things that we wish to do. I tend to use odd numbers of segments because that way, for example, if I want to feed it at a particular point, so let's say I want to put a transmission feed line right in the middle of this wire here. That way I know if I put that at segment 5 that there will be an equal number of segments, that's 4 either side. That's the reason, but it's really up to you. Okay, so that's segments. Also, each wire will have a tag. Notice here it has a tag. That's just simply a number. It's a way of identifying it. It's like if you're on a train station, platform 1, 2, 3, etc. It's the same thing, nothing more complicated. Now you notice this has got 15 segments. Sorry, this is segment 15, so obviously this has got more than 9 segments. If you have a look at this wire here, it's on segment 7, and by clicking you can have a look at which segment you're on. That's segment 9. It doesn't really matter, I just thought I'd point it out. Also, there's this little round thing here. That is actually the voltage source. That's the feed point. It's denoted by this little circle here. If you click on it, it'll give you a little information box, and it says this particular one is at wire 1, tag 1, segment 5. Now this wire has got 9 segments, therefore it's right in the center, segment 5. It also gives you the values, the voltage, the power assumed, the SWR. And you notice the voltage is 688 plus J0, which basically means it's in phase. The current and voltage is in phase. If this J was if it was something else apart from 0, then the voltage would be either leading or lagging the current. It doesn't really matter for our purposes. Let NEC do the work. Okay, so now let's have a look at the editors. First of all, we select the Notepad editor and we click on it, and here we have, it's just a notepad, standard sort of Windows notepad, nothing special except for the data included. Now if you have a look, the first one is we have a column, a group of values here. These are basically identifiers. They describe the type of information which follows. CM means a comment, SY means a symbol, GW means a wire geometry or geometry wire. FR is frequency, 300 megahertz in this case, and so forth. So you get the idea. We can simply use this like any other notepad type of editor. You just have to make sure the fields are valid. It uses tabs to delimit the fields here, so just thought I'd point that out. And there you go. We'll have a look at the information included in here a little bit later, but we need to get through the editors. Okay, the next editor is the NEC editor. Again, we select it here in the settings, and then after we've selected it, we just click the editor button. Now this is very similar to the Notepad editor, except that this one has got some intelligence in it. So let's say, for example, that we want to add a comment here. Now, so we'll click on this particular one, and notice it gives us the line, and it shows us what those values are. So let's just go through it. It says GW, which is basically saying it's a wire. It has a tag of 2, which is the identifier, and it's this particular line here. Wire there, this one here, highlighted. It has 9 segments in it. It has an X, Y, and Z of 1. So one point is X, Y, and Z of 1. And the other point is -1, 1, and 1. So it's just basically identifying the beginning and end in 3-dimensional space. Now this wire rad is the dimensions of the wire, its radius, how thick it is. Now if we wanted to add some more, we can just click on the line we want and we press insert, and that will put another line after it. Now let's say we just wish to put a comment on. So let's have a look, and there is CM, so comment line. Just click underneath here and it will, whoops, and we can just put in whatever we wish to say, and press save, and there we go. Now if we wish to see what the effects of our changes are, we just press this calculator button here. It says we have some errors. We won't worry about that at the moment because this is just a demonstration file. I know it has some errors in it. Okay, so we can delete that as well. Press save, and away we go. Now let's say we want to remove a wire. We can simply go there and remove it. Okay. If we wish to, just one thing I will add. Let's say we wish to put in another wire, and we select this. If you just click under here, it will actually give you all the information already there. Now it's the same as the original one, so remember you need to change it to another tag. So we've already got 1 and 2, so we need 3, and so forth. So then you can change the number of segments, the beginning X, Y, and Z, the ending X, Y, and Z, and the radius. But we'll just forget about that one. So we'll delete it. Oops. And we'll save that first, and then we'll delete it. Also, we'll delete this second line here, this particular one, and we'll save it and recalculate. And it says wires 1, tag 1, and tag 2 and overlaid. Okay, and there we go. So we only have 1 now. So you can see you can change things in this editor. It's not too bad. Pretty straightforward to use. Okay, let's close that editor and go to the geometry editor. Now this particular editor, again, just click on that, click on there, and away you go. Now I'm going to delete these antennas or these wires so that we can actually generate our own. So you just make sure this is on the select object, press the object you wish to select, and press delete. The same here, delete. Now we're left with this, which is the voltage source. In other words, it's our feed point. It's our driving voltage, so we wish to delete that as well. We've selected it and we delete that as well. So what we're left with now is X, Y, and Z coordinates. Now let's generate a new antenna. Well, first of all, let's go to the wire geometry. Oh, I'll just tell you what these buttons up here are. The first one is wire. So this is when you want to add wire elements or rod elements, whatever. This is for voltage sources, in other words your feed point. This is if you want to add traps or coils or capacitors or anything of that nature. This is if you want to add a transmission line. This will show you a bit like the notepad editor will show you the result of your work in the graphical mode, but it will show it to you in a table. This is the frequency. You can define the frequency there, and this is the type of earth. Now these are the different views. Now you can have a 3D view where you can rotate things around. You can look at just the X and the Z axes, so you can see the X and the Z. The Y is there, but it's pointing straight at you, so you can't see it. You can look at Y and Z, so you can see Y and Z, or you can look at X and Y. You can see X and you can see Y, and Z is poking straight at you. So this is almost like you're looking from above. Okay, now when you're actually defining an antenna, it's probably best to use these rather than the 3D, because trying to work it out in 3D is not so easy. Okay, first thing to do is you can say, well, what scale am I going to use for my grid? So let's say, for example, that you wished, oh pardon me, let's say you wish to use 0.05 a meter, let's say 0.1 of a meter. So each one of these little squares down here, or the 5 squares, will be 0.1 of a meter. So each one of these will be 0.5. So if you look here, the X and Y, if we put it there, you can see it says 0.5 in the Y here. And if we move it over here, you can see it says 0.5 for X and Y. So you get the idea. The Z, because we're not actually seeing the Z at the moment, that's why Z is not shown. So let's define our antenna. Remember, we're looking from above, and this is Z looking straight down from the top of the antenna. So let's put one wire from here. Oh, sorry. You need to select on what you want to do and then add. And then we'll put that there, and we'll move that to there. So you can see we have a length of 3 meters in the Z direction. Now this says, what would you like the wire radius to be in millimeters? We'll just leave it at 1 millimeter, but you could change it to whatever you wish. Okay, well there's our first element. Now let's say here it shows us what this element is. Now it has a tag of 1, which is its identifier. It has 1 segment. Now let's make that 9 segments. We want to give it a little bit of NEC something to work with. Its radius is 1 millimeter. You could change it. Look, you've got all these different wire gauges, or you can just use the millimeters. Now this is one end, 0, 0, 0, because it's there, and the other end is 3, 0, 0, because it's there. So X, Y, and Z. If we have a look at it in 3D mode, we can see, whoops, oh, sorry, added another one. I still had it in add mode. That's the reason why, so I'll delete that. Okay, if we have a look at it now, we can see we have this antenna, but it's rather low. In fact, it's laying on the ground, because if you notice, this is Z, which is our height. So let's bring it up a little bit. So let's have a look at X and Z. So we can see the X plane and the Z plane, which is the height, and let's bring it up. And so if you have a look at Z, it's now up at 4 meters high. See here, 4 meters. Okay, let's look at it in 3D space now. That looks a little bit nicer. Okay, now we need to feed this particular antenna at some point. So let's feed it. For this we need to put in a source of energy and press add. And so there we have it. Now, so that's our feed point there. Now if we have a look here, it says 1 plus J0. In other words, it doesn't really matter what this particular setting here is, just leave it where it is. The 0 means it's in phase, so there is no phase shift between the current and the voltage. Okay, so one other important point is where you're going to feed it. Now we could move this along and put it, say, there, for example, We don't want to do that. So we could put another feed point rather, because we're still in add mode. So if we wanted to, we could move it along there, for example. Now you notice it's at segment 6, but that gives us an unequal feeding. Pretty good if you want an off-center dipole, but we don't want that at the moment, so we're going to put it back at 5 so it's right in the center. Now you can add these fields manually. You can change this there, click it and put it, so you don't have to move it along. Okay, why don't we have a bit of, we need to define the frequency. So let's have a look here, and we'll define the frequency as, I don't know, 50 megahertz. And megahertz, we're all set there. It's put down, you notice it's put down the wavelength in meters. Okay, now let's press this and calculate and generate the data, and there we go. So we have our dipole. Here we have the information on it. You notice SWR is 2.3. Wow, that's not bad just for a wild guess, isn't it? Just making up a frequency. Okay, now if we have a look at this pattern diagram here, this is the vertical plane and that's the horizontal plane. Now let's change another thing on this. Let's change the Earth. It's in free space, so let's make it over a real ground. Average, let's put it where I am. Rocky steep hills. Okay, now let's recalculate it now with the new ground, and there we go. We have our sombrero. So this is in the vertical plane, so this is looking at it from the side, this is looking at it from above. If we want some more information, press the J and it gives you the point of maximum radiation. You press I and it gives you some more information, gives you the bandwidth and a few other things, dBs, and you can drag this if you wish around, and at various angles you can see what the amount, how much radiation there is. If we have a look at horizontally, same thing. And the last thing we can do is we can press the G key, which will actually put a little diagram of the antenna. It's there. You can't see it very well, but it's there. So if you just remember JIG, J-I-G, that'll help you. Okay, so there we go. Now the last, we'll close that. I might save that first. Okay, the last one we'll have a look at in our editors is the NEC editor. This is quite a useful one as well. Okay, now we have a look here, and it has symbols. We're not using any symbols at this moment. Geometry, which is the same thing. The tag, we only have one wire, so we're looking at 1. We have 9 segments, X, Y, and Z at one end, X, Y, and Z at the other end, and the radius of the wire. The scaling is in meters. The source and load, we're using a voltage source. It's on wire number 1 or tag 1. It's at segment number 5, so right in the center. That's irrelevant. It has a real component, no imaginary component. The magnitude or the value is 1, and that's all we really need to know. The frequency is 50 megahertz. Uses the real ground. You can choose all sorts of different types, and again, you've got all sorts of different types of ground. This here, not really much use to you. Comments, again. Now, you can go through here and just add another one. Let's say we can put in a helix, an arc, or whatever you'd like, but let's just put a wire in. Again, we have tag 2. Let's make it 9 segments. Let's make this 1, 1, and 3. And let's make this 4, 5, 5, and 5. And here we'll make this 1e minus 3, which is just scientific notation for those people who obviously know it. And if we want, we can press the save button and then we can recalculate. We'll probably get some errors, but we'll say, oh no, lucky. Okay, so then we can have a look, and we've got another wire, but it's just sitting around in space. It's not doing anything, but you get the idea. Now let's say, for example, we wanted to change the height. Now let's say we want, or the endpoint. We could make this height 1. Now then we go to the symbols and we type in height 1 equals 7, for example. And then we save that, and then we recalculate, and you notice it's still there, it's fine, there's no problems. But now the difference is that we can change this height anytime we want. So we can have a look at that and we can change that to 6 or whatever. Now you might think, okay, why? Well, let's say you had a number of different points where you wanted heights, so you could have this as well, could be height 1. And so that would make it a lot easier to change heights, because then you just change this one and all the others within here would change. I'll just recalculate that. Might get some errors, but won't worry too much about it. Oh no, well there you go. As you can see. Now this will become much more useful later on in the tutorial on optimization. So we will need to use symbols for that. Okay, well I think we're probably running a little bit out of time here, so I'll leave it there. I hope that's helped you, and we'll be going through a little bit more and using some of the editors and getting more in-depth and detail. But for the time being, I hope that's helped you to at least get a start. Now with the editors, if you have an editor, like let's say for example you're using the geometry editor and you've got this antenna in here already, and you think, how am I going to get rid of it? You can, if you want, just go new, and that'll do. Then you can just go save as, and let's say you want to call it, first try. Now you can just, do it. Remember to use add. Oh yes. Anyway, it'll tell you what's going on here. It won't be a problem. So yeah, just enjoy, and I'm sure that you'll have a great time with it. The next tutorial will go more in depth into how to optimize antennas, and also we'll just go through a few of the matching, how to do matching, and so forth, using stubs and RLC networks, and basically how to design a tuner for your antenna. 73s.